Oh, hi there, everybody. Swirsky here. We're going to go ahead and get working on quadrilateral coordinate proofs. Now, to start with, we are not going to include these ones yet. Please don't make the X. I'm just doing that for the sake of knowing that we are not working on those yet, but we will do that next time we see each other. Okay? Until then, oh, I don't want that. Until then, what I would like you to do on page 17, my friends, is that I'd like you to fill out this to the best of your ability. Now, what I'm asking you to fill out is I'd like you to put an X, a check, a smiley face on which properties down this list each one of these has. Okay? So a parallelogram, we're going to ask, does it have the opposite sides parallel? Yes. Hey, gave you the first one. Go down the list and say, and put an X on all the properties that do work, and then just leave it blank if that's not a property. Okay, we just want to get an idea and kind of look at this and summarize it. So go ahead, pause the video, check it out, and then we will come back and see how you did. All right, hopefully you have this filled out. So the first one, we had opposite sides are parallel. We also know that they're congruent. We don't have all sides congruent. But the other things we have, we know the opposite angles are, consecutive angles, and diagonals bisect each other. That would be it for parallelograms. Rectangles. Hopefully you're going to get the thought of like there's going to be more. So a rectangle is a parallelogram. So it has all of these. And diagonals are congruent. And all the angles are congruent, meaning they're 90 degrees. Okay? Next one, the rhombus, is a parallelogram. And it has diagonals that bisect, diagonals are perpendicular, and all sides are congruent. Hopefully I said all angles on this one. Angles are congruent on that one. Okay? And finally a square, which is a parallelogram, and, well, really it's I guess you can say it's a rhombus, and it has the other two. Okay? So as we work our way this way to uniformity, meaning sides and angles are all lining up, you see the more properties start to happen. Okay? Which also means that there's more required in order to say that something's a square than there is then to say that something is a rhombus or a rectangle or a parallelogram. Okay? Now that works when we start talking about kind of the quadrilateral family tree. And this is kind of what it looks like. So if you want to, you can pause and fill this out. But we start with our overarching umbrella name of a quadrilateral, which is any four-sided shape. Okay? And then we can start getting more specific. Like we can split it out with the stuff we had. So we can go to parallelogram, and then there's these little branches here. Trapezoid, which doesn't quite fit the parallelogram, and same thing with a kite. Doesn't really fit the parallelogram. Because we're saying it has two parallel sides, it has two pairs of parallel sides, or a kite which has no parallel sides, so they're kind of on their own. Okay? Now I could go one more step with trapezoid by making it isosceles. And really, if I were to even out these sides of the trapezoid, I could actually shift this over to a rectangle or a parallelogram if I made it more specialized. But we are going to leave that as is. Okay? Now, after we get to the general shape of a parallelogram, if I straighten out those angles and make all those 90, that's when I get the rectangle. If I get all equal sides of my parallelogram, that's when I turn it into a rhombus. If I combine the rectangle and rhombus, that's how I finally get to the square. Okay? So you see it flows into all of these pieces. So I'll erase kind of all my stuff here. Okay? So what we're going to decide is based off of kind of our what we discover, which kind of level can we say things are at. Okay? And that's what we're going to look for. So have this family tree handy. If you haven't made a copy of it yet, pause it, do that, because we're going to move on here. Okay? So using these properties, this family tree, on the next page, what we're going to be able to say is that we want to prove something's a quadrilateral using coordinate proofs, which just means by graphing. Okay? Now this all comes down to what you can say is two things, which is side length and slope. Okay? If I find the slope and the side length of what I'm looking for, how those interact with each other will tell me everything I need to know. Okay? So if I want to prove it's a parallelogram, I would have to show that I have two sets of parallel sides, or same slope, right? Two sets of the same slope. And on top of that, I would have to also see, if I looked at some side lengths, that the opposite sides are congruent, which means same length. Okay? Now, if I want to go past that, I obviously need the parallelogram, like that. You need to see that you have sets of parallel sides and angles, but I need to add, so if I was going to make it a rectangle, just like I had here, the thing that distinguishes a rectangle from a parallelogram is the 90-degree angles. Well, how do I use slope or side length to show that? Oh, well, if I have 90-degree angles, meaning opposite reciprocal slopes. Okay? So that would mean that if I have two sets where they're 1/2, and then the other ones are negative 2, 1, right? Opposite reciprocal, then that's the opposite reciprocal slopes that I'm looking for. So again, the slopes will tell me everything I need. On top of saying the opposite sides are parallel as well. Or opposite sides are congruent. Okay? Now if I want to do it for a rhombus, remember the only difference between a parallelogram and a rhombus was that the sides were the same. Well, that would mean that I would need to look at and identify all congruent sides. Okay? Or they'd have to be shown to be the same length. Okay? And finally, to prove it's a square, I would need both of these things. Right? 90-degree angles and all congruent sides. So we're really seeing how far down the family tree we can go and what we have to be able to identify that. Okay? So let's get into one of these and I'll show you kind of what we're looking for. Okay? So we want to determine if this is a parallelogram. Now this is the first question in your packet. Obviously it looks like it, but how can we say for sure? Well, if we can use our JM, let's call it JK. These are the segments, LK and then LM. We have 4 segments. I'm going to just look at the properties I have with these. And it all starts with the slope and the side length. We'll just say side. Okay, if I can do that, I can look at, see what I'm looking for. Well, remember for parallelogram, I need sides parallel and congruent. So let's see if we can do that. Well, let's find the slope first. So I'm going, in this case, up 2 over 3. So I know JM is 2/3. Well, if I have opposites that are parallel, this slope here better be the same, up 2 over 3. Hey, it is. Okay, same thing with the one here for JK and LM. Going down 3 over 8, so negative 3, 8. I don't really care about simplifying or anything like that, but then we should see here 3, 8. That works too, negative 3, 8. Hey, first part I have. Okay, I have the same slope. What about the sides? That means I need the length. Well, do you remember find out the length of a side given 2 points or even given a graph? Use Pythagorean Theorem. Well, I just made a triangle here and here. And I know that my 2 side lengths, that I have similar side lengths here and here because I know the slopes are the same. So you could go through the stuff of going 3, 8, blah, blah, or I can realize that these parts of my slope are representing also the lengths of the side lengths of my triangle that I can plug in, where I would go 8 squared, 3 squared. I'm not caring about negative because when I square it, it'll go positive anyways. C squared, okay? And again, I don't care about simplifying. I can just leave it as a root. So 8 squared is, so let's do that. 8 squared is 64, 3 squared is 9. That would be 65, so I know that this is root 65. Well, so is this because it has the same two parts. Again, if you don't know where I'm getting that, if I were to take this and this, I would find that part, right? So 3 squared, 8 squared, C squared. Add those up. So this would end up being, what, 9, 64, which is 75, not 65. Oh gosh, I don't even know what I'm doing here. 64 and 9, 73, good golly, 73. Sorry about that. So 73, thank God I did this. Okay, and if I'm taking the square, that means I need the root, and I don't need the decimal. Just leave that. You're looking for the number. Okay, there. And I can do the same thing with my 2/3. I know this is my A, this is my B. So 2 squared is 4, 3 squared is 9. So let's see if I can do my math right on this one. 13, 13. So I want to define it as a parallelogram. I can. My slopes, my opposite slopes are the same. My opposite sides are congruent. Okay, and I actually know that my sides are going to be congruent even before I do this piece, because if my slopes are the same, I'm using the same parts. If I can get there, I know that if I do my triangle here and find C, right, 2 and 3, if it's the same thing here, 2 and 3, it has to be congruent. Okay, so those two parts fit. It's congruent, it's parallel, yes. And defend your answer. All of this work is defending my answer. I don't need a verbal description. Okay, showing me that is going to be your verbal description. All right. Let's get to the bulk of this. So I'll give you a second. Why don't you plot these points, and then we'll come back. Okay, so I got to do what? 2/3 or over 2, up 3. That's K. 8 and 4 is L. So 2, 4, 6, 8, 4. Oops, I got to erase that K and L. Let me fix this. Oops. One more down here, 3. 7 and negative 2, 7, negative 2. That's M. N is 1, negative 3 here. Okay, now just looking at this, I'm saying, well, it looks like those slopes are going to be pretty the same. I'm going to take a guess. I think this is actually a rhombus. Okay, but that means I need opposite parallel sides, and all the sides have to be congruent. So let's see if I can do that. K, L, L, M, N, M, K, N. Okay? Again, all you need is slope and side length. Find those pieces and see if you can come up with that. So find your pieces, see if you agree if it's a parallelogram or if you agree with me and it's a rhombus. Okay? If I find my slopes, let's see, I'm going, let's change color. Up 1 over 6. So 1, 6. If my other one works, that means, right, up 1 over 6. So NM, that works. Hey, one set of parallels. The next one, I'm going up 6 over 1. So this is 6 over 1. Is the other one? Yes, it is. Up 6 over 1. Up 6 over 1. So I got the first part of parallels. Now let's see what the side lengths do. We'll realize that I'm dealing with the same set of A and B points to find C on each one, right? I've got 1 and 6, 1 and 6, 1 and 6, 1 and 6. So I'm going to get the same value for each one, 36. So 6 squared plus 1 squared equals C squared. 6 squared is 36. 1 squared is 1, so this is root. All of them are. Ooh, all the side lengths are the same. I have two sets of congruent, or of parallel lines. That means parallelogram is not the most accurate, and a rhombus is the winner. Okay? That's the basis for what we do. So even before we are trying to defend something, find the slopes, find the side lengths, and then make your decision on what you got. Okay? So here is mine. I'm giving kind of my opinion. So I filled everything out already. Okay? So I'm saying the most specific name is a parallelogram. Am I right? Why or why not? And then if I'm not, what should I get? So am I right? How do you know? If I'm not, what should the real one be? I'll give you a second. Pause it. See if you can figure out, based off of all of this stuff, what that's telling you. By the way, AC and BD are diagonals, which you can use, but again, not necessary. Go. All right. So hopefully you saw a couple things. I got all the same side length, and I got two sets of parallel lines. Well, that means that it's not just a parallelogram, it's a rhombus. Okay, that's the more accurate name for it. Because, and if you want to answer that, I'm not going to write it down. Because not only do I have opposite parallels, but then all the side lengths are not just two sets of them, but all of them are the same. So because of this fact, I know that I get my rhombus. Okay, everybody, that is all I got for you. We are going to, from there, you're going to go ahead and hit some class kick up, get some practice in, doing the same kind of stuff. Remember, find your slopes, just like it's shown in here, okay? Find your, did I skip one? Oh, I did. Let's call this the end here. Let's call this success then. Sorry about that. So let's try it. So let's go start to finish. Tell me, or prove to me that this is a parallelogram. Okay. So mark your figure in the graph. Show me your slopes and show me your slopes and your distances, and then prove to me that it's there. Give it a shot. All right. So let me find my pieces here. So I got to go -2, 4, that's F, 3, 5, G, 2, -3, that's H, and then -3, -4, that's J. Right away, this looks pretty darn good. I just need to see on these parts. So I'm going to go FG, GH. I'm going to mark the 4 parts, JH, FJ. Okay, let's find the slopes. If I do the slopes for all of them, so FG would be up 1/5. Does JH do that too? Yes, it does. And then the other one is up 8/1. So for all of these, I know I have two sets of parallels. Now I just need to see two sets of congruent side lengths. Now remember, this is my A and B. So I have 25, or 5 squared plus 1 squared. So I get root 26, which means I'll get that here. Same thing with this, 64, this is root 65. Here's my proof. I have two sets of congruent sides, two sets of parallel sides. That means it has to be parallelogram. Okay? So the nice thing is that it's pretty repetitive as far as what you're looking for. And then you just have to kind of describe what's going on and work from there. Okay? Now, the rest of your time is going to be on a class kick. It's also going through your practice in your packet. That would be number 5 through 12. You have some challenge problems on 13 and 14 if you want to give it a shot. Otherwise, 5 through 12 is your requirement. Let me know if you have questions. I will see you on the next video.